In this video, we're looking at solving equations using backtracking. In this question, we're given some information. I'm going to break down the information for you. The first sentence says, there are X mice in a cage. X is the number of mice. We do not know what this number of mice is. The pet shop owner moves more mice into the cage so that there is now double the number of mice for sale. The pet shop owner moves more mice into the cage, so there's now double the number of mice for sale. What does that mean? Well, it means if there was 5 mice in the cage at the start, the pet shop owner has doubled the number of mice. There would now be 10 mice. If there were 8 mice at the start and the pet shop doubled the number of mice in the cage, then there would be 16 mice in the cage. Monique buys 3 mice. 1. What does the variable X represent? As I said at the start, X is the number of mice in the cage. So X is the number of mice in the cage. Number 2 says to us, write an expression for the final number of mice in the cage. Okay, so let's go and work this out with numbers first. If there was 5 mice to start off with, then the pet shop owner doubled the number of mice. Doubling means timesing by 2, so we'd have 2 times 5, which is 10 mice. Then Monique bought 3 mice, so we would have 10 mice in the cage minus 3, which leaves a total of 7 mice in the cage. Now it says write an expression for the number of mice in the cage. So now I'm going to do some working. Instead of having 5 mice a number, we're going to have X mice. So what happens here? The pet shop owner doubles the number of mice. That's 2 times X, which is 2X. Then we have Monique buy 3 mice. Well, we have 2X mice in the cage. Monique buys 3, so there's going to be 3 less. So I've got 2X minus 3. So write an expression for the final number of mice in the cage. It is 2X minus 3. Now we'll move on to question number 3. Question number 3 wants us to draw a flowchart to build this expression. So we're starting off with X mice. We are going to now work out the next square. And the next square is where the pet shop doubles the number of mice, so times it by 2. So timesing X by 2, we get 2X. Then Monique buys 3 mice. So there's going to be 3 less mice in the cage, which means we have in the cage now 2X minus 3. Question number 4 says to us, what is the final number of mice in the cage when X is equal to 5? Just like my example just now, so we know the answer is going to be 7. So when X is 5, I have 2 times 5 minus 3. 2 times 5 is 10. So I have 10 minus 3. 10 minus 3 is 7. And you can see that was the same as what I did at the start as a trial. Part B says to us when x is 13. So same steps. 2 times the number of mice, which is 13, minus 3. 2 times 13 is 26. So we have 26 minus 3. 26 minus 3 is 23. So there would be 23 mice left in the cage. Moving on with the question. We're then asked, how can you work out the original number of mice when you know the final number? If the final number of mice in the cage is 15, write 15 under 2x minus 3 on the flowchart. So we've got the flowchart now sitting under question number 5. This is the same flowchart that I have said just now. The only thing different is the 15 is written underneath the 2x minus 3 because that was the final number. Now it says to us, on your flowchart, copy the extra boxes and arrows shown in this diagram. Write the inverse operations to backtrack from the final expression into the starting variable. So the first part's done. What we're going to be doing is backtracking. So we're going from the 2x minus 3 back to the 2x. So we had 15, and the opposite to taking 3, the inverse operation, is plus 3. So 15 plus 3 is 18. Continuing going backwards, the opposite to timesing by 2, the inverse operation, is dividing by 2. So if we take 18 and we divide it by 2, we get 9. 9 would be our starting value. What have we done here? We've done step 5. Use backtracking, working in the opposite direction. That was my backtracking. What is the value of x when backtracking from 15? X is equal to 9. We can see the x and the 9 pair up, the 2x and the 18 pair up, and the 2x minus 3 and 15 pair up. Question number 8 says, you have solved the equation 2x minus 3 equals 15. What is the solution? Solution means answer. So what is the solution to this equation? It is x equals 9. Question 9 says, explain what equations represent and what the solution tells us. The equation 2x minus 3 equals 15 tells us about the mice. What it tells us is that after the pet shop owner had doubled the number of mice in the cage and 3 had been bought, how many mice were left? What the solution tells us was how many mice we started off with. Example 1. It says to us, copy and complete the flowchart, write the equation to be solved and its solution. So we're going to start working with the going forwards. We're starting with x. It says x divided by 4. That means x over 4. We're now told to add 5 to it, so x over 4 plus 5. So it says, write the equation. So the equation is going to be x over 4 plus 5 equals the box underneath it, which is 8. Like before, those two boxes go together. So here is the equation. Now we're going to use the backtracking. It says to us -5. Now we've got the number 8. So 8 subtract 5 is 3. Then continuing the backtracking, it's got times 4. 3 times 4 is 12. So x is equal to 12. I've got the letter by itself. That is the solution. So the solution is x is equal to 12. Here is example 2. We're going to be doing example 2 using our flowchart first. So the first thing we're going to do is we start off with the letter x. Inside the bracket, there is a -1. So we're going to subtract 1. So that gives me x minus 1. Outside of the bracket, there is a 3. That means we're timesing everything by 3. So 3 times. So what I now have is 3 times x minus 1. Now we're going to do the backtracking. We're told 3 times x minus 1 is equal to 24. So what I want to do is fill in the other two squares going backwards because we are backtracking. Okay, from x minus 1 to 3 times x minus 1, I times by 3. The inverse operation to timesing by 3 is dividing by 3. So my new square is going to be 24 divided by 3, which is 8, which I've now written into square. On the arrow above, I've got a -1. So on the arrow when I'm backtracking below, then I have the inverse operation to -1, which is +1. So I've got 8, and I'm plussing 1, I get 9. So I have now got x is equal to 9. X equals 9 is my solution. We were asked to solve, which means we had to find what value x was equal to, and using backtracking, that was the bottom line of my flowchart.